of this sediment include
sand.
This is a shoreline. The shoreline is the space between high and low tide.
In common language, a coast means anything around the water, so everything is a coast. But in geographical terms, the coast is just the land that is unaffected by the tide. So as you can see, I have my seaweed high tide limit here, which means above this, where I am, is a coast. And if I keep walking,
I like that. That was good.
I'm standing here on the high tide limit. I can tell what this is because the seaweed here has been pushed up by the tide. When the tide brings it in, it deposits it here and recedes back out without taking it back. This is also the line where there's a lot of logs because these logs used to be driftwood. They came in, but since they're heavy, it's harder for the tide to pick them up and take them out than it is to push it in. I'm going to tell you right now how longshore drift works. So, as you can see, the water's pretty calm right now, so there's no real waves, but I'm going to pretend there is. So what happens with longshore drift is small particles, or in this case big particles like myself, are going to come from the southwest, and what happens is swash and backwash. So swash in the wave pushes the particles in like this, and the backwash is always at 90 degrees and it comes out. And then swash happens and it comes like this, and backwash, and swash and backwash.
Constructive waves are waves with a stronger swash than backwash. They build up beaches by bringing in sediment from the ocean. Deconstructive waves, on the other hand, eat away at beaches by carrying the sediment back into the sea because their backwash is stronger than their swash. The waves we have here at White Rock are constructive, so to demonstrate the deconstructive wave, we made an interpretive dance to represent the sediment being pulled back into the ocean. We know that the waves here on White Rock are constructive because the swash is not only more visible but also stronger than the backwash. Water breaks because, as the bottom of the wave approaches the shore, it comes in contact with the sand, and due to the increased friction, it decelerates. The top of the wave, however, does not, so it becomes steeper and steeper until the wave eventually falls over and breaks. This was an example of hydraulic action, as the water got in between the cracks in the rocks and broke down the rocks. Attrition is the process of erosion when rocks hit against each other and wear each other down. Abrasion occurs when rocks and sand rub up against the land, like a nail file or sandpaper. Corrosion is the process in which the salt water in the ocean chemically breaks down the rocks on the shore. We did not see any evidence of this at White Rock Beach. White Rock Beach is a bay, surrounded by two headlands. A bay is created when the water slowly erodes at the softer rock and creates an arc-like shape in the land. Headlands, however, are made of a harder rock, so it is much harder for the water to erode them. This creates the U-like shapes in the land that you see, like this one.
Hey Bryden, what you doing there?
Oh, I'm just sunbathing. You know how it goes.
You sure about that?
Yeah, it's beautiful.
So where are we anyway?
Well, we're on Blackie Spit. You see, this beach is actually nice because what happens is you get particulates and sediment from the Nickameckle River coming here, over there, and they come over here. Then, longshore drift happens from Crescent Beach, where you're pointing now, and they came together. And then they started accumulating, and that accumulation started acting as a groin, and it pushed the sediment, collected, and now it's all the way out here. And it's beautiful. Woo!
probably tell just from flipping through the housing market listings, the real estate along White Rock Beach is extremely expensive. This is ironic, as coasts are some of the most vulnerable places to live. To protect the homes and businesses along the beach, humans have implemented many defenses and adaptations to slow down the erosion of this area.
I'm standing on a groin. Now, as you can see, the purpose of the groin is to prevent longshore drift to carry sediment down there and carry it and erode the part of the beach over there. So what happens is the groin is here, and as the longshore drift, the swash and the backwash carry the sediment, the groin will stop it. And as you can see, the sediment buildup on this side of the groin is way higher than it is on this side.
Jump, 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 jump!
Hey, what's up you guys? I am standing here on a riprap right now. These rocks are not naturally occurring. They were put here to prevent coastal erosion. Because without these rocks, what would happen is the waves would come up here and they'd slowly eat away at this land that you're standing on. But the city comes and they put the riprap in. These rocks here are harder to break down for the water than the sandy ground that you stand upon. So right here, it's very hard for the beach and the water to erode at these. So what happens is that the water will come and it won't eat away at the rocks, and the rocks prevent it from getting to the land and collapsing it. The one problem that occurs though is that the water will get in between the rocks and can eat away at the sand here. So for example, I can stick my hand way down in here because there's nothing there. Probably because the water would have come and taken all the sand and sediment out.
This is a storm sewer overflow. Now, when it gets stormy and water overflows into the city, this acts as a way to take the water back into the ocean. The water can come out, but it can't go back into the city.
On the railroad, as you can tell, but what you may not know is that this is also a dike. Now, if you pan around, you can see that this railroad is elevated compared to either side. The reason for that is that it acts as a dike. If the water levels rise, this dike will prevent the marine drive and all these businesses from flooding.
The most prominent evidence of historic use in White Rock Beach is the railroad that connects British Columbia to Washington State. In the early 1900s, this railroad was used to bring tourists from Vancouver and New Westminster into places like Crescent Beach and White Rock. There is also evidence of the milling operations that served to boost White Rock's economy in the past.
The economic activity down here on the beach is evidently different than something you'd see somewhere inland, because there are lots of little souvenir shops to do with the sea, and also they sell food for hot days like fish and chips and ice cream.
In the event of a storm surge, the first coastal defense in White Rock Beach would be the riprap. However, this would not be very effective, as you can see, in major cases, the land behind the riprap has been easily eroded. The dike, on the other hand, would be somewhat effective in keeping the water out of Marine Drive. Lastly, the storm sewer outflow would help to take the excess water out of the city. Together, I think these three coastal defenses would be enough to protect Marine Drive from flooding in most storms. Serious storms may be a different story. In the event of an evacuation, it would be likely that the residents on Marine Drive would have to go up to higher ground.
I will remember you. Will you remember me? Don't let your life pass you by. Weep not for the memories. Remember the good times that we had. Let them slip away from us when things got bad. Clearly I first saw you
this leg is